All right, we will now start introducing our next two speakers. We have a dream team coming up for our last session of the morning. We are going to be hearing from Doctors Amy Reibman and Jackie Boerman. So Jackie Boerman, some of you may recognize her, and she will be moderating our graduate student sessions, which I encourage you again to stay tuned for. But Jackie is a faculty member at Purdue University, working on projects utilizing large amounts of data that dairy farms produce, including automated lameness detection and predictive models for calf growth. And she has been collaborating with Dr. Amy Reibman. Dr. Reibman is a professor of electrical and computer engineering. She came to Purdue 6 years ago after 23 years of industrial research at AT&T Labs. So Dr. Reibman's technical interests are in image and video quality assessment, video transmission, and video analytics. And I believe Dr. Boerman is going to be speaking first. So I will hand the floor over to her.
Thank you. So when we were planning for different talks, we thought that maybe we should have a video talk because that seems to be a popular area in dairy research. And I didn't feel ready to give that talk. So we also brought Dr. Reibman in, and she's going to be talking more about video analytics, what that actually means, as well as real world challenges. But I thought that I could start by setting us up with what types of video are already used on farms, what are some things we may be able to detect using video, and then turn it over to Amy, who's going to do the harder part. So when we think about dairy farms, a lot of times they're already using some video. So large commercial farms may already have surveillance cameras on. So they're looking at specific parts of the farm that they want to monitor. And this could be at those points in the farm where you have human and animal interaction, like in the milking parlor, or it could also be certain equipment areas that you want to monitor. In this image, we just have a couple of videos of the parlor, both the pre-dip and the post-dip area, as well as the holding pen as cows are walking from the parlor and you have groups of animals entering into the rotary parlor, as well as some points where you have equipment. So maybe you're looking at delivery of trucks, milk trucks, or you're looking at specific equipment to make sure that things are going appropriately. So we already know that farms are utilizing video, but when we talk about potential for video on farm, anywhere on a farm that we rely on human observation, there's the potential to use video analytics. So let's brainstorm. I'm sure that everyone on this webinar can think of 10 or 20 things that they could use video for if we just use that broad definition of anywhere that we rely on human observation, we could use video. Here are a couple of examples, but think of more and then have questions for Amy at the end for how we would actually do this. So there may be technologies in place. Sorry, so Amy's running, so we have a hard time figuring out what I'm saying and when we should click forward. So there may already be technologies in place, but some examples are like, is this animal in estrus? So should she be bred? Is this heifer large enough to breed based on her weight relative to mature body weight of the herd? Does this cow have mastitis? So there may be applications for using video actually to detect milk in the parlor. Does this cow show any signs of illness? That's very broad, and Amy will get into an example of that later on. Are cows gaining or losing weight? That may be information that's valuable to your nutritionist, but also potentially your veterinarian. Are animals being handled appropriately? As we think about these critical human and animal interaction points, video may be a way that we can evaluate if animals are being treated appropriately. And we all know that that is a concern in the dairy industry. So maybe a point that we could use video analytics to evaluate that. And then just a pertinent point now is where I live, we're still harvesting corn silage. So potentially we could use it for deliveries onto farms, like how many loads of corn silage have been delivered. So when we think about what we could use it for, let's take a step back and think what has already been used for what we've already looked at when it comes to video. So a number of papers are in the literature. The first example is body weight estimation. There's a number of papers that have looked at body weight estimation using video. This is just one example. The second is motility and how able that animal is to walk. So this is really just lameness detection. And then the fourth is behavior. So that is a nice review that was done by Caitlin Wirtz looking at behavior of animals and if we could use video in order to detect differences in behavior. So I just want to show one example of mobility. So they used 3D images to locate an animal, and then they found specific points of that animal, and they were trying to detect lameness by looking at the height differences of those specific points. So you can all probably tell we're looking at the top view of a cow. And in the last image, we're looking at specific points of that animal. So you see the top line, and then you see the hooks and the pins located by those points. And they look to see changes in height difference as the animal was moving. If we think about that as a cow that's lame is moving, they're going to have a bigger difference in height than an animal that is walking smoothly and doesn't have any issues with lameness. So I thought that this was an interesting way that they have used a 3D camera in order to look at lameness. So why hasn't this been adapted to commercial farms? So a lot of times these research studies have been done on a pretty small subset of animals. In this case, they require 3D cameras, which are pretty expensive and maybe not going to be put onto dairy farms as their first foray into video analytics. And then a lot of these systems are designed for research, but not necessarily application on farm. So we can do a lot of cool things, but maybe not everything that we're doing in research has application on commercial farm. So the next slide talks about what has been done on commercial farms and what companies are doing with video on commercial farms already. So this is an image from Canthus's website. So they use video systems to monitor feed availability. So you can see this person is hanging a camera up. They're hanging it above the feed area, and it's used to monitor feed availability and then give an alert to the dairy farmer about when feed is low or when cows have not enough access to feed. So this is doing some cool things that we need to do in order to use video analytics on farm. First, it's collecting the video data at the site. It's processing that information in real time, and it gives actionable information to the farmer about feed availability. And that should clue you into all of the things that need to happen in order for video to be useful on farm. And now I'm going to turn it over to Amy, who's going to talk about video analytics and what that actually is, as well as some potential problems that we may have with implementing it on farms.
Thanks, Jackie. So, yeah, okay, so what is video analytics and why should you use it? Basically, video analytics is to automatically extract usable and actionable information from video. And there's lots of advantages that video provides relative to human observations. It never gets tired. It can always pay attention, never gets distracted by something that passes by. And so you can use it 24/7 if you have sufficient lighting. It's also repeatable and systematic so that you get the same type of answer given the same input video every single time from the video analytics system. You can have multiple simultaneous viewpoints, so you can be looking at the scene from lots of different angles. And you could plausibly have new vantage points that maybe a human couldn't use because the human couldn't see it. And so another really important aspect here is that you can actually get, if you've done proper calibration of your cameras, you can actually get length measurements as well. And so you can humans can estimate length, but if you have your camera system designed properly, then you can get much more accurate estimates of length from the camera. And honestly, one of the reasons to use it is basically there's so many advances happening these days. It's like every 2 days you turn around, you wake up and there's some new advance in video technology, video analytics, and so forth. And so it seems like this wonderful, wonderful thing. So why not use video analytics? Well, like I said, every 2 days you wake up and there's hype about something new in the popular press, and there's a lot of hype. And I want to warn you all not to expect miracles. So it's really easy to mount a camera to observe the dairy operations. And then it's really difficult to actually design an effective system that goes from image capture to actionable output in a way that actually can work on the farm, can work given the constraints on the farm, and as actually telling you something that you want to know, as opposed to whatever the system can tell you. So how can one distinguish between the exaggeration and an actual plausible opportunity? And how can you avoid overinflated expectations that cannot possibly be met? So if we think about the list that Jackie gave us on the left is all the different things that you might consider about using video analytics for. And then you have on the right, you have the notion that, well, this is what you'd find as you look up and you say, how do I do video analytics? It says, get the data, label the data, train the machine learning algorithm, or design it, train it, evaluate it, and then go back and do it again. But there's really this huge gap between these two in terms of what does it even mean? What does get data mean? What data do you need? Label data? What do you mean by that? And so what our approach here is to try to bridge the gap between these two things. So to try to fill the hole between the desires of the dairy on the left and the capabilities and the design methodology of video analytics on the right. And so the strategy here that we believe in is to educate dairy experts just enough about video analytics so you know what it can do and what it's capable of and what it's not capable of, and also educate video experts just enough about the dairy needs so that we can be designing systems that are actually going to work on the dairy as opposed to only work in a pristine situation in the lab. So to kind of bridge this gap and to try to get started in this conversation, I mean, really focusing on getting the data is the important part. But what I'd like to do is take one of the topics from over in Jackie's list and then just kind of dig into it in terms of the questions that we'd have to go through to design a system, a video analytics system that would actually do this. And so we'll choose the application or the task of, does this cow show signs of illness? So let's think about some of the questions that would need to be asked here. What are typical signs of illness in a cow? We're going to be using visual cues, so we have to have visual signs of illness. How does the illness affect the cow? Can we see this effect visually? Do we need to see the cow moving in order to see these signs of illness, or can we just see it from a single snapshot of the cow? And then from which angles or viewpoints can we see these signs? And so these questions may seem really familiar to you, and that's because they're the type of questions that you would actually be training somebody who needs to do the visual observations. You'd be teaching them these exact things about what is it that they need to be looking for, when can they see the signs, and so forth. And so these should feel very familiar to you. And I think of these as the questions that the dairy expert needs to answer that the video expert will have absolutely zero clue about until she's educated. So then the next set of questions is actually where the video expert and the dairy expert start to talk. And it's questions like, is it easy to automatically get the cow into that desired viewpoint? Is there a place to mount the cameras that are close enough to be able to see her well? So that's all about the design of the video camera system in the physical dairy. Will there be sufficient lighting for us to see her well? And will there be other objects blocking our view of her that sit between, that we just really can't move, or we don't want to force these objects not to block her if it's going to disrupt the daily operation of the dairy? And so other questions that we would have to ask is just how are we going to get the video from the camera to the computer so that the computer can do the analytics? And will the video be in an easy to manipulate and not proprietary format? I'll talk a little bit later about how our first foray into this, we chose a cheap DVR camera system, and then we had a nightmare once we started to get that video into the lab to try to process that video and to even get it off the DVR system. So so then the next set of questions I think of as the questions that the video expert needs to think of as she designs her system. And this is did we capture a good quality image? So before the previous slide, we're talking about how are we going to get a good quality image? Now we're asking, did we get a good quality image? Is it in focus? Did we inject too many compression artifacts as we were trying to get the data off the camera and over to the computer? We might use video compression, and that might really make it look pretty hard to see details that we want. Is there sufficient lighting? Are there objects between her and the cow? Did we capture her at a good angle? These are all questions that we would then need to know the answers to design our video system appropriately. And finally, the number one question that we need to ask as we design our video analytics system to do any kind of processing on a cow is just where is the cow? So this sounds like, you know, you tell your toddler, show me the cow in this picture, and your toddler says, moo cow, you know, finds it instantaneously. So this is the challenge of video analytics, is it's not a trivial process to identify the cow in the image. It's not a trivial process to find out which pixels in the image correspond to the cow. If you can overcome that level, then you can start to do the things that video gives you all these advantages of that I mentioned earlier. But if you can't find the cow in the image, you're kind of stuck. So we did a case study just recently accepted for publication in the Computers and Electronics and Agriculture. And so we did a case study of monitoring video as cows as they exit the milking parlor and returning to their freestall pen. So the main principle of our design is that there should be no modification to the the daily routine of the farmers or of the cows. And ideally, we could use the eventual goal would be to do some kind of lameness detection or weight estimation or body condition score. But the first step is what we've taken first is where is the cow in the image? So we want to locate every cow as she walks. We call this a mask of which pixels correspond to the cow. And then we want to describe the cow's walking pose or structure, which we'll call the key points as well, which basically says where, like which parts of these pixels correspond to which parts of the cow. So a few quick notes, the dairy has 1,800 cows. Almost all of them are Holstein, but some are brown Swiss, and that'll come in a minute. The cows are observed twice a day. And again, we don't modify the routine of either the farmers or the cows. So our camera system evolved over the course of the 3 years that we recorded. We started out, as I said, with this inexpensive surveillance DVR system. It was a nightmare, low quality images, hard to get the data off. We did a trial run with a GoPro camera just to see if we could get better quality with a better quality camera. We decided that yes, we could. The GoPro has the challenge that to get the data off, you either have to compress it wirelessly or you have to take out the disk and swap it in, and it's kind of a menial task and hard to do. So then we designed an IP camera surveillance system using off-the-shelf pieces, power over Ethernet switches and so forth. And so that was our final design. And it's nearly fully automated. It turns on, starts watching the cows as they exit the milking parlor, turns off until the next time it needs to turn on, and so forth. And it automatically takes the video from all these cameras that we have and stores it onto disk. And so here's an example of the 4 cameras that we have installed in the dairy. And you can see that for the same cow here, we have a simultaneous view of her from 4 different angles. The top left is her as she's going to be walking towards us. The bottom left is a top view. We have cameras on the ceiling. The top right is the main one that we'll be using here in this talk, which is a side view with just a few fences and no blocking cows. And then this bottom view, bottom right, looks like it's a better image than the one on the top, but sometimes there are cows blocking the way of us being able to see this one cow that we care about. And so actually the top view is a little bit better for our purposes for here. And so this is at one moment in time, and then we see her again. I mean, we're recording the entire video, but just to show you, we can see her again at another instant in time, and we can see how she's moved through the process. So as I said, we have these 3 camera systems, and they all were viewing the cow from the same basic angle. They had different spatial resolutions and temporal resolutions, and we wound up using the camera 3, which these are shown to scale, so it has the most pixels per cow, so the cow is seen the most clearly. And in all cases, we can kind of see that the quality of this image, it's not like the cow jumps out at you and says, wow, that's where the cow is. So the cow is being blocked by these fences, and the video analytics has to deal with those. So just to give you a sense of how well different methods, why we needed to create our method to figure out where is the cow in the image. Here are 4 particular frames of the cow on the left, and then I've labeled the ground truth mask here. So this shows what we want to be getting out of the where is the cow in the image. And then I'll show 4 different methods to do this. The first 3 are other people's methods, and the 4th one is our own method. So if we look at these other 3 methods, what we can see is that in the top row, there's a person, and this one can't distinguish between the person and the cow. This one does a pretty good job just finding the cow, but it's still missing some points. Here we have multiple cows, and this one, the ground truth, we see there are 2 cows. This one merges them again together. This one's even worse. It just sees this big mass of blob. This one's missing some details here. And so forth. So this particular 3rd row is actually interesting because it's a white cow. There was no white cow in our training methodology. And so what we see is that this 3rd method, method 2, actually in here can't see the cow at all because it was trained on Holsteins, and this one has no markings, and so it can't see the cow. And then if we look at our system added in here, Zoom conveniently is blocking my view, but we see that this looks much better in terms of the number of cows that we find. We're able to distinguish each of the cows, and we're able to ignore the person because the person's not a cow. And we actually do a really great job finding the white cow, even though we've not done any training on the white cow. So our method relies on a structural model of the cow, and it relies on our current assumptions that the cows face and move to the right. And then we're looking at a basic simplistic skeletal structure or structural model, which shows the points of the head, the points of the body, and then the legs associated with this. And here's an example of what our video analytics processing steps would be. So the top left again is the ground truth. If we just use the off-the-shelf stuff that existed before we did our system, then we find the middle top picture where we just find a few points of the cow and we don't really have a good sense of the cow. If we add some post-processing that we have to that output, before we create the output, we do a little bit of post-processing and recognize that a cow should look like a cow. We're able to find a lot more points of this cow over here in the top right. We can also use supplemental information to use the temporal, how is the cow moving as she walks. And then we can do some post-processing on that and then merge the results, and we get a very clear picture of what part of the cow is where in this image. So just to show you an example of this system and process. So here's an example of a video with multiple cows walking one after the other through the milking path or the exit path. And each cow is going to track each color is going to track a different cow. And so you see that sometimes the points get lost. We might have some confusion down in the legs, but then sometimes we can see the legs pretty well. And in fact, we're able to partition all these cows and for each cow automatically identify that, yes, there are multiple cows and these parts of this cow, these parts of a cow belong to this cow. So just some why we chose this approach with the structural model and what are the advantages of our system relative to what others did. And I think that I'm telling you this so that you can kind of understand that video analytics is challenging. And one of the things is that our method is robust to obstacles like fences and humans. So we can see that it's finding the cows through the fences. It's able to isolate each cow even when they're close together, and it's robust to the white cow even though it had never seen a white cow before. It's basically doing all this by incorporating what they call domain knowledge, which you would call basic human knowledge. And it's recognizing that each detected cow should look like a cow. It shouldn't look like a Picasso painting with a head underneath its udder and a leg up top. And so by imposing these key point constraints, we can do a lot better. And because we have these key points, we can also use that information for future analysis. So one of the projects that we have ongoing right now is to estimate cow weight. So we're taking that structural model in the lower left here and measuring parts of the animal to estimate her weight. And we're also taking some information from the front view video to see her from more of a top view so that we can get a better sense of the width of the cow. And so this is, as I said, ongoing progress, but it's building really directly on the structural model that we have. So in terms of, we haven't solved everything here, not surprisingly. So the limitations and challenges here to try to apply this to your own situation is that one is the environment where the cameras are, in terms of the lighting, the fences. The cows may be covered with dirt and manure. The dirt may get on the camera. There's a lot of moisture, which may damage the camera. The manure would make the cows look differently, potentially. There's also questions of what are you going to do as you put this into your farm. Is what are you going to do with the information? How is the information going to be useful? At this stage, you know where the cow is. You don't necessarily need what we have, but as I said, our current contribution is to be able to do the groundwork so that we can build on top of it to do the meaningful information extraction. Do we need the information in real time, or can we process the video file overnight and get answers the following morning? Where are we going to store and process our video? And obviously, if we can't see it, the video can't see it either. So if you had some type of illness that wouldn't show up visually, then don't use video. And the camera quality makes a big difference. One of the things that's sort of hidden in all of this is that the data, you may need a huge amount of data to design your video analytics to make it work well enough for your needs. And almost always that data needs to be labeled. And sometimes that data needs to be labeled by experts. So you can teach somebody like me what it means for a cow to be lame, to look at the head bob, to look at the pattern of the rhythm. But you may also really want an expert to be labeling the lameness of the cows in order to get good estimates from your system. And so really the next steps that Jackie and I foresee to be able to get video analytics into the dairy is to really figure out where are the major needs of the industry and figure out, can video help? Would video be able to help? Would a human be able to do it from the video that you capture? And how can you then build a system that does it automatically? And we really do believe that you're not going to be able to sit dairy experts down and get them to solve it. And you sure as shooting aren't going to be able to get video experts to sit down and be able to solve it for you. You need to be trying to both cross that bridge to connect in the middle so that the video analytics is actually doing what the dairy needs and the dairy understands the limitations of the video analytics. So with that, I'd like to thank you for this opportunity. It's really exciting to be working in this area and applying these tools to cows and dairies. And thanks. Any questions?
We have one that just popped up in the feed. Could a system be able to measure weights and heights and growth rates in heifers?
So I think so. I think there are a number of things that have to happen. You need to be able to figure out, go back to that list of questions. Can you see the animal at a position that allows you to find the key structural lengths of the animal and to be able to measure those? I think that so one of the things that made our current system much more manageable is that the milking cows were walking systematically and we just took advantage of that systematic path. In order to do it for heifers who might be in an open pen, you would have to be able to identify when you saw each heifer in an appropriate angle that allowed you to get accurate measurements from it. So it involves a lot more work. It's not just like, oh, there I waved my magic wand and sprinkled some fairy dust and it worked.
And another thing for heifers too is on this path, we are IDing the animal based on the sort gate that's preceding it. So we have an ID of those animals. If you were interested in the specific body weight and height of an individual animal, you'd also have to be able to ID them. If you're interested in the body weight and height of a group of animals and you don't care about the individual, I think that could be easier, or it would require less interaction with other technology to identify them.
Mm-hmm. You mentioned while you were talking, you showed the white cow that the camera couldn't identify as a cow. How hard is it if you were to, for example, try to, you can identify a cow now, you're going to use it on a Jersey dairy, and they're not only a different color, but they're significantly smaller. How hard is it to teach this software that now, okay, do you have to completely reteach it and start from scratch, or is it pretty easy once you have the basics down?
So I think that in this case, we do have some constraints about how far apart the head would be from the center of the cow. But I think if you added the flexibility to have, multiple sizes of cows, it would be fairly straightforward, and the system would pretty much, there would be very little training that would be involved. We'd just have to add that parameter to the system.
Mm-hmm. We have a question here. Would you be able to assess heat stress through a video system?
So if we can assess so my understanding is that heat stress causes behavioral changes, and that it would be the behavioral changes that we would be looking for. You could plausibly put up a thermal camera that might be able to detect the heat, but I think that my understanding is that the hide of the cow doesn't show many instances of it doesn't show elevated temperature. So you'd basically only be getting that from the eyes. So I think that you would have to look at the behavior, and then you'd have to figure out what behaviors matter. And I should really let Jackie fill in some more there.
No, I'm so proud of how much you know about cows, to be honest.
I'm so proud of how much you know about video. So
yeah, I think you're exactly right. I think that people have done some infrared cameras, and it may not be sensitive enough to pick up on changes in heat stress, because really when we're talking about heat stress, it's internal core body temperature that we're worried about. And the eye is what they're doing in humans. I don't know if we've done a ton of it in cattle, but they think that, especially with COVID, we've seen a lot of temperature monitoring done just on the inside corner of the eye. So that's a potential application that we could extrapolate to cows and see if it's effective as well.